So we're very pleased to have Tim here presenting today. Tim's been one of the passive house pioneers in New Zealand and also been doing a lot of projects down south. If you're not aware, Dunedin's got a lot of multi-unit passive house that Tim's been involved in, and also a lot of single-family homes. He seems to have quite a good pipeline of Instagram posts of new blower door tests and new certified projects coming out quite regularly, which is great. So do look up Tim or look up Architype on Instagram and on LinkedIn as well, I think. Today we've asked Tim to come along and particularly talk about multi-unit passive house projects, because there are a number that are finished in New Zealand, and it's good that we're aware of them and people can be inspired and realise that actually these are quite possible. And Dunedin's not the easiest climate for doing passive house in New Zealand. So if Tim can do it in Dunedin, we can all do it in other parts of New Zealand. Over to you.
Put a timer on. 20 minutes, right?
Yeah.
Cool. Well, kia ora, everyone. So as Elron said, my name's Tim Ross. I'm an architect and passive designer. Work for a practice called Architype in Dunedin, or principal of a practice called Architype in Dunedin. And for the next 20 minutes, I want to present a few of our recent multi-unit projects. And I want to try and convince you all that multi-unit apartment and passive house projects are demonstrably superior to code-built alternatives in almost every metric. And my objective is to encourage us as kind of passive house enthusiasts to encourage decision makers that going passive on their projects is actually a really sensible decision that they won't regret. Assuming they're working with an experienced team, it should be the obvious decision. You've seen this graph a few times, but I thought I'd just take an opportunity to say why we as a practice got into doing passive house buildings. Obviously, you can see the, put quite simply, the rich countries of the world are in the process of destroying our stable climate. And it's this very stability that has supported our prosperity over the last several thousand years. And so we really don't want to be damaging that. So about 10 years ago, our practice discovered passive house, and we were instantly hooked. Here was a methodology based on physics, which prioritized reducing heating and cooling demand by about 90%. And that sort of happened to be about the amount that we needed to reduce to avoid catastrophic climate change. So for the last 10, 12 years, we've been focused on developing workflow details and a local passive house ecosystem, which allows us to deliver passive house projects for which are accessible to a wide range of clients. We have on the screen 16 certified passive house buildings under our belts, comprising 56 homes, because a lot of them are multi-unit. We have a bunch more on site, a lot more on the drawing board, and even a few that are complete, just awaiting final details of certification. We've also done lots of low energy non-certified homes over the past 10 years, but we really encourage our clients to certify whenever possible. And it's interesting to note that of these projects, 34 of the homes are rental properties. So really good mix there. Our strategy as a practice is to influence decision makers by delivering buildings which demonstrate the superiority of low carbon, passive house and fully electric design. And we define the term superiority as health, comfort, affordability, climate, livability, and durability. Actually, I'm just going to go back one slide there. Because we believe that once we have enough of these projects out there and we've demonstrated that they're superior, financially and in terms of comfort and health, then we really, in some sense, will have kind of won the battle, and it'll only be a matter of exposing people to these ideas and slowly building that transition to a zero carbon built environment. However, like other emerging clean technologies, at this point in the evolution of passive houses, there are some use cases which are easier to demonstrate superiority than others. I use the analogy of EVs. EVs are great. If your use case is, say, a taxi in Wellington, where you're going to drive 200 kilometers a day, it's easy to demonstrate superiority on almost every metric. But if your use case is that you need to tow 3 tons, 1,000 kilometers a day, then you're still going to struggle to demonstrate superiority. And I think it's the same with passive houses. It's not super easy at this point to prove, to demonstrate superiority if you're building a house and flicking it on for profit, because you are going to be working with a much smaller segment of the market who will, reward you for your triple glazed windows and your ventilation system. But standalone, yeah. But when if you intend to build and rent apartments, then we think that you can convincingly argue that passive house is superior in every way, including financially. And a few years ago, we kind of suspected this was the case, but now we have a number of completed projects which we've monitored, and we can have a look at some real world data that proves, or we think proves this point. It's a little bit subjective, but still. Many of you will be familiar with this project, so I'm not going to go into too much detail about it. Toyota co-housing, 21 passive house homes and 3 retrofit homes which weren't certified. The project was a collaboration between ourselves and eHouse, and it's also coincidentally where I live. So yeah, I'm not going to bore you with more details about the project, but I am going to delve into some of the numbers, particularly power consumption and temperature and humidity. And yeah, I can certainly attest it's a great place to live, and it's all running. Been there 2 years, it's running really well, and it's a great wee neighbourhood. So some of the numbers, we have 24 homes, 21 of those are certified passive. The build cost pre-COVID was $2,650 per square metre for the buildings themselves, not including site development costs. And not including GST. And carbon emissions over 90 years, we've calculated at 630 kilograms of CO2 per square metre, and that's a 50% reduction from the baseline, according to LCA Quick. Total power bill for 2023 was 20 grand for all of the 24 homes, plus some of the common facilities. And that included 8 residents who own EVs. Now we've got 12. There's the numbers increasing quite rapidly. And of those 8 EVs avoided 8,000 odd litres of petrol. So this is a screenshot from our power bill for the 2023 year. So we spent 20 grand as a neighbourhood for the whole year, and if we convert that to kilowatt hours, we're looking at about 100,000 kilowatt hours for everyone. And if we take the EVs out of that, we get down to about 93 kilowatt hours. Because one thing I was really interested in was looking at the power bills was how much were the EVs contributing. I was wondering if the gains from passive house would be somewhat offset by the EVs, but it really turns out they contribute very little. And I've got the next graph shows that quite clearly. So yeah, we're using about the same amount of power as 11 average households in Dunedin, and I suspect that average household would probably include homes with wood burners as well, which wouldn't be included in the average number. So, and they're not heated as well. That's right, they're not heated to 20 degrees. Some of these drop below 20 degrees, and we'll see that later on as well. But people don't always turn on the heaters. So yeah, it works out, if you just roughly work that out, divide it between 24 homes, in 12 months, you get power bills of $67.50 per month per household. We got 3 kids at home at the moment, so ours is a little bit higher than that, but on average, it's $63 per month. So I went through all of these spreadsheets and all of our hot water meter readings and the plug load meter readings, and basically turned this graph from our power bill into this graph to show a little bit more of a breakdown of where all the energy was being consumed. So very, very roughly, the orange and yellow were the plug loads. So that was the meter readings taken from people's houses. And I made the decision to say, well, look, we weren't heating January, February, March, and then because all of our heating is done through plug-in heaters. So we basically said, okay, that beyond that level, we're going to assume that hump is heating. And we can see our hot water. We've got a district hot water system with 1 or 2 large industrial heat pumps, and with ring mains, and they supplied hot water to the homes, and we can see that in the light blue. So you can see in summer it starts off reasonable, and it probably about doubles in winter. And then we've got the grey as our EV usage. So you can see really, even with 8 EVs, it's pretty insignificant relative to the general power consumption. And then the dark blue was was what was left over, and it was really down to we've got a sauna which people use in the common facility. We've got guest rooms which are not passive house, and they get heated quite heavily with electric heaters. We've got the common house. We have common meals every 4 days. So there's power consumption there. So those are kind of the common, outdoor lighting, common costs, common energy costs. And one interesting thing that I found was that, we're only heating about half of what PHPP predicted. So I think potentially there's been some people in there who are a bit stingy and not turning the heaters on really when they should, and probably accepting lower temperatures than they could. So here's a distribution. This is done based on some work by Michael Jack's team from University of Otago that did some monitoring. And here's the sort of the range of temperatures across a whole bunch of living rooms and bedrooms that we monitored. And you can see the odd one, generally you saw, these ones are kept pretty neatly within the sort of the range that you expect. There's clearly a few people who have accepted lower temperatures and maybe not turned on their heaters. But even then, the average temperatures are, 19 degrees. So there's that's across the entire year, I'm pretty sure. That's 1 year. Yeah. So that whole distribution, represents from summer to winter. So you've got, clearly this one here was getting some pretty high temperatures as well. I'm not quite sure what happened, why this one got up so high, but generally they weren't. These are maximum temperatures, so they never got higher than, say, 26 degrees in these homes. So it's interesting. User behavior is really interesting. Talking to people about how they use their homes, when they open their windows, if they don't, what they're doing with their ventilation systems, whether they're changing the filters. There's a lot of it's quite a shift from working with sort of standalone homes where the owners are quite engaged and often quite nerdy. And then CO2 levels. We monitored these and found, this is the band we wanted to be in. Jason was saying before, he wanted to have it into the building code that you went no higher than 1200. So definitely some of these ones would not comply. And as a consequence, we've decided that, especially for some of the smaller units where we had probably 110 square meters, and you had maybe 3 or even sometimes 4 people living in those spaces, the ventilation rates just weren't, the PHPP ventilation rates simply weren't high enough. And it's also reflected in the humidity levels that we've now started to, when we model right from the beginning, assume higher ventilation rates for smaller multi-unit projects, just to make sure that we can control humidity and CO2 levels. So, and then just to put that in context, I also went back to our previous power bills from our old villa, which we had renovated. Had double glazing, had a wood burner, had a direct electric heat, hot water heater, and some panel heaters. But it was, it was reasonably well insulated. But the blue is our power bill, is our power consumption over the year, and the yellow is the power consumption for our house in Toyota. And obviously this is, related back to what Michael was talking about, that our winter peak used to be 5 times higher than the summer low. And now you can see how incredibly flat the consumption is for the passive house. So that really lends itself to getting rid of some of those gas peaker plants or not having to build out as much infrastructure to deal with those summer peaks. Yeah, so we've gone from using 17,000 kilowatt hours per year down to around 6,000 kilowatt hours per year. And that includes children who probably game too much on their computers, and, baking lots of sourdough and lots of sort of, unnecessary energy consumption, and running two EVs as well. So onto another project that we completed in 2002, so a year or two back now. It was a student accommodation project for a local developer. He had some mouldy flats in the past. He put in some Zender ventilation systems to try and control that so the students wouldn't have to open the windows. And we were kind of like, well, if you've got Zender ventilation systems, why not just, sort out your air tightness, and you have yourself some Passive House certified apartments. And he was convinced by that. So they knocked down the old flat that was on the site. This is in Studentville, in the middle of Leith Street in Dunedin, right? There's some really interesting, incredibly skanky flats surrounding. We had some interesting objects thrown on site over the course of this build. on Friday and Saturday nights. So 3 more minutes left. Okay, I'm going to run now. CLT construction for this one. And there was a little view of it. It had really great north-facing orientation. Right from the beginning, we were considering distribution of ventilation around the units. This is basically concept stage. We'd sort of figured out exactly how the structures and everything would work. So really tight integration, learning from previous projects starting on site. Builders loved the CLT, worked really well from a thermal bridging point of view. Project going together. We did something that we think was reasonably innovative around the ventilation systems. We've got these chimneys that kind of collect each of the ventilation systems supply and return, so that we don't have a whole bunch of grills on the outside of the building. And they kind of then picked it up and took it out some cowls on the roof. Blower door testing was interesting. We had these AAVs on the top of our plumbing stacks so that we didn't have to have plumbing penetrations through the roof and sucking in cold air. And yet when we came to do the blower door testing, those would kind of allow a lot of air to go in. So we learned that for future reference, we need to make sure they're accessible so we can remove and close them off during blower door testing. And similarly with our ventilation systems, we used these dampers and we thought, yeah, we're going to be able to shut them off and do our blower door testing and that'll be fine. But they were completely leaky and no good for blower door testing. So we had to actually cut out chunks of the ducting, insert balloons, inflate them, seal the ducting, do the blower door test, and then pull them back out again. So thinking about doing your blower door testing, how you're gonna do that is also an important kind of consideration. Lots of work to try and make sure that the occupants understood how the windows work. This is what the ventilation system is going to do. Filters will be needing to change. So educating tenants who move, who are particularly new every year, and making sure that the management of the buildings is easy. Got like 1 minute left, presumably. So numbers on this one: 19 certified passive apartments, where the build cost in 2022 was 4,150 a square metre, which is due to the fact that you had, for every bedroom, you've got a kitchen and a bathroom. So they're really quite high value 1-bedroom units. Total project cost was 6 million, including land, furnishings, everything. And straight away, the value was 9 million, was what the value was, told the guys. So they were getting really good rental returns. This had 140 framing in Dunedin, no services cavity. Really should be a no-brainer. And then I'm going to race through this one, the Dunedin City Council pensioner flats. We knocked down this, which was arranged like this. We thought, let's arrange it like this. So we've got private on the outside, we're around public space, and then we managed to have these sort of 2 identical blocks. So they end up sort of laid out on the site like this. Design, we had 3 months from concept design to detail to lodging building consent. So it was incredibly tight, and we didn't have any time to be like messing around with new solutions. So we just had to kind of like grab from our kit of parts and just go, boom, here's a solution that we know is going to work and be certifiable. Just going to rush through the details. One of the keys to making these projects work is tight integration of the ventilation system. And at the moment, we find that there just aren't the contractors out there who know how to do this well. It requires coordination with the plumber, coordination with the electrician, coordination through the airtight envelope, really good seals around everything, and also tight integration in terms of the design right from the beginning. So that way they get neatly taken up within the kitchen there. So there's units when we finished. Blower door testing went really well, and the feedback from the tenants has been fantastic. Like going from a cold flat to a Buckingham Palace, like chalk and cheese. Power bills have halved. So there's really been very positive feedback and the council was happy to pass on all those comments. Again, a district hot water system that's been really reliable. No sort of problems there. And then they've done some monitoring as well. So we really need to work with these guys to get into the numbers a little bit, but we've seen similar kind of things. This is an end unit. So we can see there was one, this is pretty much representative of one day in March where they did find it got quite hot. But generally you can see that, I think that's the 75th percentile. So it's staying well within sort of the range that we're after. And then there's definitely underheating going on as well. People are just not turning on their heater. But in some ways, if they're comfortable putting on a jumper, that's kind of their prerogative. They save the money and still remain reasonably comfortable. Well, that does make me wonder about FRSI values when I think if the temperature's getting down that low, and maybe they should be heating a little bit more. Humidity is great. These are single occupancy homes. CO2 is really good. And just briefly in the pipeline, I'll talk a little bit about this project later on. It's the Loco. This is the townhouse Loco project. Another duplex project which we're currently building in Christchurch. 2 passive houses back to back. The idea is to, we've designed this to be kind of expandable later on. With steel structure already in place, so that if they need to increase the density in the neighbourhood begins to densify, we don't have to like knock things down. They can just kind of like increase density. Got another 28 units in for building consent in Dunedin, as for aiming for certification, and another duplex lodge that's just started on site in Waimate, and a whole bunch of other projects at various stages, but those are the ones that kind of quite advanced. So yeah, that's me.
Which we got? Wine or not wine?
So